Hey guys, what's up? Today we're going to build a trading strategy in Python. We're going to write an algo that is able to find the best entry and exit points for a given share. On the chart, we can see the green and red arrows. They are indications on when to buy or sell our stock. As a benchmark, we are going to use buying or selling one share, and we're going to compare it with our strategy profits. We are going to see when the strategy is profitable and when it's not. As a disclaimer, this is not a financial advisement video in any way. This is just a Python tutorial. And we are going to try not to rely in third-party libraries much. We are going to write the code by ourselves. Hope you code along with me, and if you have any question, just leave it down below in the comments. Thank you for watching. Okay, so let's open the terminal and let's start by installing all the necessary dependencies for this project. So let's write pip install pandas and yfinance. Just press enter, and after your installations are completed, go into Jupyter and create a new notebook. So I'm going to name my notebook as trading strategy. You can name yours whatever you want. And I'm going to start by import all the necessary libraries. So pandas as PD, let's give it an alias, and let's import yfinance as yf. So this yfinance is our way to get our financial data. So we're going to use this Yahoo API to give us like the financial data for a given stock. So let's start by writing yf.download, and we have to pass a ticker here. So in our case, we are going to start with Tesla, and Tesla ticker is TSLA. I'm also going to pass like a starting date. I don't want all the financial data of Tesla since it went public, so I'm only interested on the data from the 1st of January. So I'm running the cell, and now I have all the financial data back. We are only going to use the close price, so we don't care about open, high, low, or the volume. So let's take a look in our close price. And we're going to use this column to calculate our simple moving average. So what is the simple moving average? Well, it's just the average of the prices of a window of time. So if we take, for instance, the last 15 days here, or 15, sorry, we can see that we have this distribution of prices. So in the first day we had 83, and the last day we had 113. So we want to calculate the mean of these prices, right? So we can just pass the argument mean in our data frame, and that will give us a value back, so 98. So it means that in these 15 days, the average price was 98. Okay? But we don't want to do that like for just one window of 15 days. We want to do it for all the windows of 15 days. So thankfully, we don't have to go into a for loop and do it for each of these 15 days. We can directly calculate it in pandas. So we can just do the f.close. We can use the method rolling. We can pass the window of days that we would like to calculate our simple moving average. So in our case, it's 15 days, as we saw above. So let me just print it here. So these 15 days here. And we're going to calculate the mean, okay? So if we do that, we can see that each day has now a mean. So you can see these NAs, and as you can imagine, like in the first day, there's no 15 days before. So you cannot calculate a mean for this entry here, right? The same here, until you actually reach the 15th day. And here you already have enough data to calculate your mean. So let's actually give it a proper column in our data frame, and let's call it just simple moving average. Okay? And let's take a look in our data frame, and let's just take the close and the simple moving average. We don't care about the other columns. And yeah, let's also take just the first 20 values. And as you can see, you don't have simple moving average for these prices, again, because you don't have prices before. But here from the 22nd day, you already have something, right? And this value is exactly the value that we calculated above. So if we go here again for these 15 days, and if we write min to take the min of these 15 values, we can see that we have 98.47. And here we have 98.47. So we are doing these calculations for each of these entries. So in this day here, the 23rd day, we are taking the 15 days before, right? So from the 2nd until the 23rd. And yeah, so we rolled our min through the data frame. It's very handy. And now that we have that, we can actually make our data frame just these two columns, because again, we don't care about the others. So let's just do it. And the next thing to do is actually to drop the NAs, because they don't have any value and we don't care about them. So we're going to use the method drop NA. And we are going to pass in place equals to true. And that just make our changes persistent. So if you don't pass this argument, the next time you run your cell and your data frame, you'll see the NAs will still be there. So let's run this piece of code and let's move on. So now that we have that, we would probably also like to reset our index because we don't necessarily care about the dates right now. So we can just use the method reset index. Okay, and we're going to pass the in place equals to true again. And here we go. Now we have a clean data set with date as a column, close, and simple moving average, and also our steps here on the left. Okay, and here this number 254 is just the number of days that we actually are using. So cool. We can get rid of that, and we can now simply plot our lines and see how do they look like. So I'm going to use matplotlib. Actually, we have to import matplotlib. So let's import matplotlib.pyplot as plt. And here we are going to initialize our figure and give it like a figure size. And our figure size is going to be something like 1610. You can play with these values. This is just the dimension of our figure. And we're going to plot our df date, so our column date in the x-axis. And we're going to plot in the y the simple moving average. And we're going to give it a label of simple moving average. And we're going to do the same for the close price. So here I'm going to call it price, and I'm taking the column close. Okay. Here we can just say plt.legend to make our legend appear. And here we go. So we can see like these two lines. One, our price line, right? And the second one is the simple moving average. So the simple moving average is the blue one, right? And the price is the orange one. And we can see how they actually intercept each other, right? And we're going to leverage this interception to figure it out when is the best time to buy or to sell our shares. So here, for instance, we can see that when the simple moving average crossed above the line price, the price went down, right? Or it kept going down. So here would be like a great moment to actually sell our share, right? So it would be good to have an indication on selling a share here, right? The same happened here when actually like the price went up and the simple moving average crossed below the price, right? So here will be like a great moment to buy. And we're going to use this to actually build up our strategy. So when these lines cross, we're going to have like an indicator telling us to buy or sell the share. So that's how we're going to do our calculations. So let's start by actually doing it in a smart manner without, again, using third-party libraries. And we are going to do it calculating the difference between these two lines. So let's call it diff. And this difference is just like our df close minus our df simple moving average. And now we have the difference between these two things. How is that helpful? We'll see in 1 minute. But basically, we can see that when this difference is positive and suddenly changed to negative, right? In that moment there, we could have a sign or a signal telling us that the lines just crossed and we have to buy or sell our share. But yeah, let's see it in more depth. And here we go. You can see our diff here. And here the close price is above. So we have like a positive diff. If we, for instance, take the head of 30, let's say. Yeah, we can see here, like in this moment, the lines just crossed. And now the simple moving average is above. So this case here, okay? So we can get this sign here, like around March, I guess. Yeah, so yeah, end of February, that the lines actually crossed. Okay, that's what we want to calculate. So get all the cases when it crossed from positive to negative. Yeah, and let's do that. So the first thing to do actually is to like initialize a new list, and we are going to say that our diff, and we're going to pass it to list. Okay, now we have a list with all the differences here, and now we're going to loop through this list. So let's start by actually initializing some things like the buys. So when we have a buy, or when we should buy our share, we're going to update our dictionary with this entry, and the sells. So let's have it here. We're also going to have the position. This is more like an indication for ourselves to recognize when we are in a buy or a sell moment, okay? We're going to see how that unfolds in the loop. So let's do for e in range len of L, our list of differences here. And we are going to get two variables here. So C for the current and P for the past, okay? And now our C is just going to be our current I, okay? So the current step in the loop. And the P, it's going to be the past step in the loop. So I minus 1. But these are not prices, these are just the differences between the close prices and the simple moving average. So the next variable should actually hold the current price at this step, okay? So we can do current price equals to df.ilog I and then the close price, okay? So if we actually get our data frame here, what we're doing is looping through all of these entries, and we are checking like what is the difference at this step and what is the price, right? So the current price in this case here, in the first case, is just 113, and our C is just like this 15 here, okay? And our P it doesn't exist in this case, right? Because this is the first entry. But for the second, like our C is this 13, our current price is this value, and our previous price is this, our P is this 15, okay? So you can explore, by yourself. I think that's the best way to actually learn it. But what we're going to do now is check if the C was negative and the P is positive. So if the current price or the current difference is negative, and the previous difference was positive. So if we have that, we are in the sell position. So position equals to sell, okay? And now we want to simply update this to the sales dictionary. So we're going to update it with the current step, so the date itself, right? So it means like this is the step 0, for instance. And we got like, we want to update our price as well, right? So we're going to have it here, and we're going to update it with the current price. Okay. So now that we have that, we have to do the same for, the other case, when the C is bigger than 0 and the P is less than 0. So if this is the case, we are in a buy position. So our position is equals to buy. And we're going to do the same, but we're going to update our buys dictionary. Okay, so buys.update I and the current price. And just with that, we can actually check in what kind of position are we. Are we in a sell position? Are we in a buy position? And yeah, so that's already very useful. But yeah, let's get more in depth to what's happening here. So basically our C is, again, the difference between these two lines, right? If the difference is positive, like in this specific step here, the difference is positive. But when we cross here, the difference is now negative, okay? Because the simple moving average has a highest value than the close price. So that means that we found our crossing point. And we want to get these crossing points and put them in dictionaries. One for the buys and another one for the sells. And that's what we're doing here. So we already have like some of the logic ready. And now that we have that, it would be good, first of all, to also have the last crossing. So meaning this last crossing here, right? So it would be good to know what would be our profit like here at the end of this, right? But these lines are not crossing. So we're going to do something artificial, and we're going to assume that when we are here, we're just going to close our position, okay? So to do so, we just have to write another if statement. And our if statement is just going to check if our I is equal to the len of the list, -1. And if that's true, and our position is on the buy, right? We have to sell it. So we're going to update it to the sells. And here I'm going to copy it because it's exactly the same thing. Just be careful with the indentation here. Okay. And else, it means that we are in a sell position. So we have to buy it, right? So again, let's copy paste this and paste it here on the buys. These indentations are awful. Yeah, so now that we have that, we're just missing one last step. That is like to get our profit. I mean, with just this piece of logic, we already know when to buy or sell our stock. But actually, we would also like to know how profitable is the strategy, right? Because we need to change our strategy. We would like to use different tickers and, So to do these comparisons, we have to make it more flexible. So we have to calculate the profit. So let's initialize a profit variable here, and let's initialize it with a value of 0. And with that, we can simply start to see how to get the profit when we are selling. So to do it, we can simply have the last buy, and I'm going to explain it in the graph a bit better in 1 second, but just bear with me. And we're going to take from the buys dictionary, and we're going to take the maximum buys key. Okay, I know it sounds a bit confusing, but what we're doing here is basically going to the buys dictionary. So let's say that we had a trade and we trade long, so we bought the stock, right? What we're doing here is to check what was the last stock that we bought. So since this is sequential, and if we are here, we can check what was the last time that we bought or sell a stock, and we can calculate the profit between these 2 points. So here we are selling the stock, and here we are buying. So we can check in our buying point, when did we actually sell the stock, right? So we can use these dictionaries to help us out. So this is the last buy, the price of the last stock that we bought. And with that, we can just take the profit as plus equal, so we're adding to the profit the current price minus the last buy. Because again, if we are selling the stock, it means that we were in a buying position before, okay? So we can simply do that. And yeah, we have our profit inside this variable now. We just have to do the same for the buys. So we have to check the dictionary for the cells, right? So we can say that our last cell here equals to the dictionary of the cells, and we are taking the last cell, so you know, the maximum of the cells key, because again, like, these keys are incremental, right? So the first key is 1, the second is 2, and you're on. So yeah, we have the last cells. We can just calculate the profit as having the last cells minus the current price. Okay, yeah. And yeah, you can see that this is different, right? So when we are calculating the profit for a buying position, we are basically taking the current price. So like, if we are in a buying position like here, right? So we are taking like this price and we are subtracting to this here when we start our buying position. But if we are in a sell position like this one, right? The calculation is different. So we have to take our initial price, our sell, and we have to take the current price minus the current price, right? Because if we are selling here, our profit is with, you know, the trending going down. So that's, the direction is different. So again, here we have the current price minus the last buy. And here we have the last sell minus the current price. So opposite things. And with this, we are almost ready. We just have to add the same thing here. So we can add our profit plus equals the current price minus the last buy. And we have to get the last buy as well. So the last buy is actually, let's just copy it, is exactly the same. And let's do the same for here, the cells. So last sell and profit. And let's have it after the update, actually. Yeah. Okay. And yeah, with that, we have everything that we need. We can just make it, you know, slightly better for us, and we can print some information while we actually are doing the calculations. So we can do something like print and entering price. And our entering price here is just our last buy. So we enter the trade with our last buy variable, okay? And our exit price is just like our current price. We also need to print our position direction. So our position direction is just buy in this case. And we want to add like our profits. So we have profit, and here we can have yeah, the difference of these two numbers. Okay, we could create a variable, but yeah, for now let's just leave it like that. And let's just print, you know, a line to separate from the other positions. So this is when like we are buying. When we are selling, we have it here, right? So we are going to print basically the same information, but we want to say that our entry price is not our last buy, is our last sell. Our exit price is still our current price, and the position is sell. And here we need to get this here. So last sell minus the current price. So that's how we calculate sell positions. And the last step is just like for the last one, we can do the same. So here we are on the position buy, so we copy this one. And the other one is on the position sell, so we copy this one here. Let's put it here. Again, these indentations are, you know, They don't like copy paste. And I guess that's everything. Let's just run and see what we have. An error, of course. Yay. So let's see. Cell last. Okay, so here we have kind of a bug on our cell. Let's take a look. And what is the error? Arg is an empty sequence. Okay, we're missing one small step, guys, because in the first, like when we're initializing our logic, we actually have to check if, you know, there's any bias. Okay, so that means like if we are in the beginning of our sequence, like here, there's no bias yet, right? So we cannot check what was the previous position. So we have to do a quick if statement to check that, and we can do if the len of bias is bigger than 0, then we can do our logic here and calculate our profits. Otherwise, we don't have anything to calculate, right? So we don't care. Let's do the same for our cells. So here, before the last cells, we can do if len cells is bigger than 0. Then we can just, you know, execute this piece of code. And for our last price, we don't need this if statement, right? Because we are sure we are like on the last step. So no if statement here. Okay, let's run it now. And here we go. So now we have like our P&L, right? We can see the difference between our positions and our profit. So let's take a look in the first one, right? 159 and 107. So yeah. So we started probably here, 159, and we went down here, 107. So our profit is, yeah, around 50 bucks. Oh, pretty good, right? Anyway, let's actually build a quick visualization to see like our entry and exit points. And let's do plt.figure again. Let's initialize our figure. Let's give it a fig size and 1610 as well. And let's start by plt.plot, and we're going to plot exactly the same two lines. So let's be a bit lazy and copy it from here. Also the legend. Okay. Let's just take out the dates because we kind of don't need it now. And now we have to plot two more things, the bias dictionary and the cells dictionary. So we're going to do plt.plot, and as x we are going to pass like our bias.keys, and we have to convert this to a list. Matplotlib is very picky, and we're going also to pass the bias.values, also converting it to a list. So let's do it like this, list. Okay. Now the next thing is to pass like the symbol. So if we're going to buy, we are going to pass this symbol here. And we are going to give it a label of buy. Let's close parentheses. And yeah, this is it for the buys. Let's do the same for the cells. So the difference is a V here instead the other sign. And here we have the cells dictionary. And here we go. We have another error. So bias.keys. Yeah, we are missing the parentheses here. Oh, we have to actually, yeah. And nice. Now we have our chart, right? We can see that here, this is our position when we are selling. And here is when we are buying. Okay, so if we go to the description again, is the 159, our entry price, and our exit price is 107, like here, 107. And you can see that for every single thing, basically, right? So our last one, it's like around 400, and we are in the buy position. And yeah, let's see our profits. So it's the last one, minus 436. That means that we have a small bug, guys. Okay, here he is. So it's not Bastian, his position. So let's run it again. And now we can see that our last price is $846. And if we run again our graph, we can see that, yeah, the last point is actually a selling point. So we are selling our share here. So good, we found a bug, that's always good. And now it's time to see if this strategy is actually profitable or not. So let's start by printing our profit. And here we go. We have $474 of, not profit, but like our value, our portfolio value would be around $474. So if we would invest $98 or 100, I mean the price at the 1st of January here, and if we had like implemented this strategy, we would now have $474. But is this like a good value? Let's find out. Let's see what would be our profit if we just had bought the share at 1st of January here, and if we had held the share until today. So we can just take like our df.ilock, and we're going to look for the last price, so the price today, and we're going to subtract our price from the beginning, so 1st of January. So let's do that. And here we go. So the profit is way higher. Well, if we had bought a share here and all the share until today, we will have like $732 back. Okay, so it's very different. But that means that this strategy never works? No, not really. There are actually cases where this strategy is way more profitable. So let me give you one quick example. So instead of Tesla here, let's go to the beginning of the notebook and let's use Beyond Meat ticker. And we're going to run the notebook again till the end. So all the cells. And look, the profit is completely different. So in this case, we have $112 back, when if we had bought the share like in the beginning of the year and all that, we would only have $18 back. And why is that? It's because this share, Beyond Meat, has had a lot of volatility in the past year. So look at the chart. So we have a lot of downs and up trends, right? So this is perfect for our strategy. And it actually works in shares that have like this behavior, so these prices. And you can check that with other, volatile shares and see if the profit is still higher than buying or selling the share. And if you find some good shares, just leave it down below in the comments. And as for the tutorial, that's it. So hope you enjoyed it. And if you have any comments, just also leave it in the comments. Thank you for watching.